Hello, everyone. I would like to show you my presentation on Ediacaran Rangea and its role as a link between the continents. The classical Ediacaran macrofossil Rangea schneidereni was first discovered in Namibia as far back as at the beginning of the 20th century. Most of the findings of Rangea come from two regions, southern Namibia and the White Sea coast in Russia. One specimen was also found in southern China. In Namibia, remains of Rangea are found in sediments of the Dabis Formation of the Nama group, belonging to the late Ediacaran. They are found in a redeposited state inside sandy lenses, filling underwater paleogatacasts. In this slide, you can see the cross-section of the paleogatacast. The fossils are preserved there in a form of three-dimensional casts. Here you can see some examples of the lens with the fossils. Rangea, along with the Pteridinium and Ernietta, is a typical member of the Nama Taphonomic Association of Macrofossils. Here you can see Pteridinium. In the White Sea, the remains of Rangea are found in several localities, including the most famous one, Zimny Gore locality. They are preserved in the same type of burial event horizons as in Namibia. Here you can see a paleogatacast lying within interbedded mudstones and siltstones. This style of preservation is called Nama style. And the fossils here are preserved as three-dimensional casts in a redeposited state. Nama burial event horizons were formed as a result of transfer and burial of bodies in a stream of sandy suspension. Here you can see the formation scheme for this burial event horizons of Nama type. In the Nama type, bodies of high density containing sandy inclusions are preserved. They represent the Nama Taphonomic Association. the second one, this scheme. On the reconstructions, Rangea was presented as a frond-like organism with a stem and an attachment bulb. And Rangea was compared with the sepants of the family Venatuliaceae. Together with many other Ediacaran organisms, Rangea combines into a group of so-called frondomorphs or rangeomorphs. For example, Chernodiscus also represent frondomorph. The bodies of frondomorphs are often fragmented, and the fragments are preserved separately. For example, on this slide, we can see the imprint of the front part of Chernodiscus. The next slide shows the imprint of the attachment disc, which represents a positive form of Aspidella tyrannoica. Here we can see the sandy filling of the stem base. Remains of Rangea are preserved in a similar fragmentarily manner. The front can be preserved separately, as well as lateral tubes and basal bulb. However, as recent studies show, unlike the frondomorphs, Rangea did not have a stem, and its front consisted of 6 lobes, and not 2 lobes, as in Chernodiscus. The lobes themselves were folded in a zigzag manner, and the transverse elements separated by the ridges of the folds on both sides of the lobe carried characteristic frondomorph structures in the form of small feathers. This one. The base of the axial shaft of Rangea was filled with sand grains during its lifetime. From the axial shaft, 6 lateral shafts extended to the side, limiting the lobes along the outer edge. The complex of these shafts was a special part of Rangea's body, which was already filled with sand particles during the life of the organism. Based on the morphological features and basal location, it had a supporting function and contributed to the anchoring of the sedentary organism to the ground by increasing the weight of the lower part of the body. Putative attachment structures of Rangea, resembling the positive form of Hospitalia novica, are found in localities of the Flinders-Belamorian style. Here you can see the burial event horizon of Flinders-Belamorian style. These positive forms of Hospitalia, which could represent putative attachment structure of Rangea, are preserved in the form of casts at the bottom of sandy layers in situ, together with the remains of epibenthic Ediacaran organisms such as Dickinsonia, Kimberella, Tribrachidium, and so on. There is a fundamental similarity of the body structure and the preservation mode of its fossil remains between Rangea and typical frondomorphs of the genus Charnediscus. The similarity is also increased by the unity of habitats. Based on the arrangement of the imprints of the attachment discs, Rangea lived in the same places as the stocked frondomorphs. Rangea is an iconic member of the Nama Taphonomic Association, which forms the basis of the fossil assemblage of the Nama group of the Kalahari Craton. But the same Nama association with a similar generic composition is distributed in some localities of the Redkina horizon of the White Sea area, which belong to the Baltica continent. Comparison of the general lists of genera of macrofossils shows an extremely small degree of similarity of fossil assemblages of Namibia and the White Sea area. The values of different similarity coefficients range from 0.05 to 0.13. However, it is worth comparing the fossil assemblages using only the same taphonomic associations. In our case, Nama Taphonomic Association. The lists of taxa from the Nama burial event horizons of the White Sea area and Namibia are quite extensive. But they need to be clarified since many genera have already been revised. Several genera are common between the assemblages of the White Sea area and Namibia, such as Pteridinium, Namibian form, which was also described as Encrylovia or Anegia on the White Sea material. The fossils of the group Protecheurida were also described in both the White Sea as Vendaconularia and in Namibia as Protecheurus or Vendaglossa. Eurechia from the White Sea and Ausia from Namibia most likely are also synonymic genera. Swordpuntia was described from both the White Sea and Namibian localities. At the same time, Ernietta is absent in the White Sea area. And while Ventagerus is an endemic form of the White Sea localities. Two more genera which are absent in Namibia are Chernodiscus, both attachment discs and imprints of the front. And a tube-like fossil Calyptrina. Comparison of the revised lists of fossil genera of the Nama style preservation of the White Sea area and Namibia shows an extreme similarity of Nama and the White Sea. The values of different similarity coefficients range from 0.5 to 0.66. And through them, it shows the proximity of the Kalahari Craton and Baltic. This may become new evidence of the global uniformity of the marine microbiota of the Earth in the late Ediacaran. There is still very little information on South China, but future findings could add more knowledge on this matter. Thank you very much for your attention.